Good morning, students. Today in this video, we are going to discuss about the basics of sequential circuits. So, in general, your digital system that can be classified as in two types. One is your combinational circuit, and another one is your sequential circuit. So far we are discussing about what is a combinational circuit, examples of combinational circuits, and then basics of number system conversion and all. And now we are going to discuss about the basics of sequential circuits. So the sequential circuit that can be again further classified as in two types. One is synchronous sequential circuits and another one is an asynchronous sequential circuits. So again the synchronous sequential circuit that can be classified as in two types, Moore model and Mealy model. Similarly, asynchronous circuit that is having two circuits based on the modes we are using inside it. One is fundamental mode and another one is a pulse mode. So first we have to see that what is a sequential circuit. So sequential circuit is nothing but actually it's based on again the combinational logic circuit. Again in the combinational logic circuit, if you are getting the output of this combinational logic circuit, again that will be given as a feedback, that is your feedback to your input, then it is said to be a sequential circuit. So see to that here, your whatever it may be a present output, it may be a 0 or 1, again that can be given as a feedback to your input of the combinational circuit through the memory. So here memory plays an important role. That is sequential circuit is nothing but it is a combination of combinational logic circuit along with the memory element. So here the examples of memory element is nothing but your flip-flop. So flip-flop that can be acting as an memory element for storing the one bit of information at a time. So for that case, we are using flip-flop. So the memory element, we are using the we are using the two devices as a memory element. One is in latch and another one is your flip-flop. So in latch, we didn't supposed to give any clock signal, but whereas in case of your flip-flop that is based on edge triggered latch, that is said to be a flip-flop. So now your present output of the sequential circuit is based on your present input as well as the past output. So that is an basic of sequential circuit. So that past output that can be given to a combinational circuit with the help of the memory element. So now the sequential circuit is said to be a combination of the flip-flops. That is called a sequential circuit. Whereas combinational circuit means it is a combination of only the basic logic gates, AND gate, OR gate, and XOR gate. And now see to that. So this is your sequential circuit. So here we are using the memory element is in two types. One is your latch and another one is your flip-flop. And the examples of your sequential circuits are flip-flop, counters and shift registers. So these are all the examples of sequential circuit. And here the time is very important because based on the time interval only, your triggering pulses that can be changes. So based on the triggering pulses only, the circuit that is working. And here clock, so clock here is nothing but it's a control signal. So based on that clock only we are going to use or enable the devices. So in clock we have a two state. One is your clock input, low input and high input. So low means that is 0 and high means that is a plus 5 volt. So similarly it can be said to be as an logic 0 means 0 volt and logic 1 means plus 5 volt. Similarly, rising edge and falling edge, edge triggered flip-flop. Now that is in the next video we are going to discuss about the falling edge and rising edge. Falling edge means that is from 5 to 0, that is high to low, that is called falling edge. And rising edge or the leading edge means that is logic 0 to logic 1, that is low to high or else 0 to plus 5, that is called your rising edge. So these are all the two types of clock signals. So based on that clock signals only, your output of the sequential circuit that can be varied. And now duty cycle. What is a duty cycle means? That is the device activated or how much time the device in the active mode, that is called duty cycle. So duty cycle T is nothing but total on period plus total off period. That is a one complete cycle. That is called your duty cycle. So now we are going to discuss about the difference between the synchronous sequential circuit and asynchronous sequential circuit. So synchronous means that is easy to design, and asynchronous means that is entirely based on your mode, which type of a mode we are going to use the devices. Okay, that is the pulsed mode and fundamental mode based on that. And here the memory element is an clocked flip-flop, whereas in case of your synchronous, but whereas in case of your asynchronous, your memory element is your unclocked flip-flop. So these circuits are faster in speed, whereas in case of your asynchronous, because here each and every flip-flop, that is your unclocked flip-flop. But here, whereas in case of your synchronous, your output of the first flip-flop that may be given as a input to the input clock pulse to the next flip-flop. So that's why it is slower in speed. Whereas in case of your synchronous circuit, and next one is your, if the input is changed in case of your synchronous sequential circuit, the status of the memory element is affected only at the active edge of the clock. So that is called your synchronous sequential circuit. If it is in case of your asynchronous means, if the input is changed, the status of the memory element is changed simultaneously. So that is called your asynchronous. And next one is, so here the examples of asynchronous are latches. So latches means here the triggering pulses we are not supposed to give to the each and every flip-flop, that is called latches. And whereas in case of your synchronous sequential circuit, we are using the flip-flops. So next class we are level trigger. Next one is your triggering method. So level triggering and edge triggering, two types of triggering we are going to use. So in level triggering, again that can be a positive level triggering and negative level triggering. So this is your examples of positive level and negative level triggering. And similarly edge triggering, already we saw that positive edge means that is from low to high, that is called positive. And negative edge triggering means that is from high to low, that is 5 to 0. So the difference between the latches and flip-flops we are going to see in the next class. Thank you.